Hello and welcome everyone. Again, my name is Matt Krokosz from Vonage, and in this session we're going to be talking about a recent redesign of our real-time unified communication platform which serves our Vonage business customers. But before we get started, let me just introduce myself. Once again, my name is Matt Krokosz. I'm located in the USA in the lovely state of New Jersey, down by the famous Jersey Shore. I have been a software engineer myself for over 27 years. I have specifically been developing software for voice over IP applications for most of my career, as far back as 1994, where I pioneered one of the first internet telephony applications for the PC. Today, I lead a team of software and DevOps engineers where we pretty much geek out building what we believe to be the best cloud-native, proprietary, real-time unified communications platform built on top of a variety of open source technologies. I know it's quite a mouthful. And when I'm not geeking out on cool technology, I like to spend the time on the water with my wife and 4 kids, whether it's at the beach, fishing, or out on a boat. Now that I've introduced myself, let me quickly introduce Vonage for those who are not familiar with the company. Vonage itself was an early pioneer in the residential voice over IP space with a service which launched in early 2001, just about 19 years ago. Vonage itself had started out providing residential landline replacement to US-based consumers, but we have since moved beyond that initial service to a much broader set of services today. Over the last 6 years, Vonage has made many acquisitions, first getting into the unified communication space with 4 UC-based acquisitions alone. We also then made several other acquisitions into the communication platform space with our purchase of Nexmo and TalkBox. And as most here are well aware, that we more recently acquired New Voice Media, getting ourselves into the contact center space. So today, Vonage is now a global software company which provides cloud-based communications across several lines of business. So Vonage Business Cloud, what is it? Vonage Business Cloud is our platform which provides unified communications as a service to our business customers. Much like New Voice Media is our platform which provides contact center as a service for our enterprise customers. For the context of my presentation today, I will specifically be discussing efforts along our Vonage Business Cloud platform within the broader Vonage organization. Vonage Business Cloud has its roots in our first acquisition of a company from Atlanta called Vocalocity about 6 years ago. And at the time of the acquisition, Vocalocity had already been providing service to its customers for about 10 years, so it's already a fairly mature offering. Our VBC platform itself is a proprietary platform where today we spend a large amount of engineering and development resources around integrations with our other lines of business, such as Nexmo API platform and TalkBox video conferencing, as well as our New Voice Media Contact Center solution, of course. We also continue to move the features and capabilities of our VBC platform upmarket while we continue to migrate customers from our other internal UC-based platforms to VBC. And at the same time, we continue to invest in the underlying technology and infrastructure in order to ensure this platform is highly reliable with cloud-based scale while also ensuring high levels of quality and security. Let's take a quick look at the specifics of the workload performed by our VBC platform, which again provides a unified communication service to our business customers. At its core, this means providing real-time voice, video, and messaging services across many different networks as well as endpoints. And at the same time, our service must perform very compute-intensive operations, such as real-time media transcoding, as well as speech-to-text and text-to-speech conversions. The platform also must support a very network-intensive application, specifically involving high levels of packets per second as necessary to handle real-time audio and video. And if that wasn't enough, the platform is also very disk-intensive, where real-time call recordings must be performed. And all of these services must work together with low latency as needed for any real-time voice and video. Platform must also support a service which is highly available as necessary to achieve 5 nines or more of uptime. And of course, the platform must be highly secure to protect our customers as well as our organization. And all these capabilities must work together to provide a global international service. So if we were to double click on the history of VBC, what we'll find is that our VBC platform went through a large and quick growth phase due to the acquisition of Vocalocity, as Vonage threw large amounts of resources in marketing, sales, and engineering towards the service. At the time, Vonage itself was just beginning to shift its focus from residential service to business service. And this meant there was now a very large organization focusing its efforts on a service previously being driven by a much smaller organization. And to be quite honest with you, the platform simply was not designed to handle this growth on many fronts. At the highest levels from a technology perspective, our VBC platform at the time was running on hybrid cloud infrastructure, where some services were still being run out of a data center and other services had simply been lifted and shifted to the cloud. We were also still managing many application and database services ourselves. And from a software perspective, the platform was a Java-based monolith, where the same artifact of running our front-end UI servers was also providing our call processing service. And although we were in the cloud, our entire platform was running on very rigid infrastructure. We had a platform where servers were very long running for years at a time, and the entire platform and application was built around making sure these servers were always running. Does that sound familiar? Unfortunately, in a cloud environment, this is not good practice. I'm sure many folks in here probably themselves have instances running in a cloud environment for years or longer themselves. And that's exactly what we had. Many teams became very attached to the rigid infrastructure in the cloud, and that practice just doesn't translate well into a cloud environment. So, Java-based monolith, acquisition, large growth, call processing, rigid infrastructure, we have a problem. So let's take a look at this problem in more detail. The problem we were having from a platform perspective was multifaceted. First, we had stability problems, where the overall architecture of the platform was very fragile. There were many moving parts in our real-time system to make even the most basic call flow work properly. And this was creating challenges with the overall stability of the platform. And as I mentioned, our platform was a Java-based monolith, where even our call processing was being handled in Java. And from an audio quality perspective, garbage collection in Java was an absolute nightmare to ensure high levels of audio quality, as it can introduce jitter during GC events. It's simply not the right tool for the job. From a scalability perspective, our infrastructure was very rigid. We're adding capacity on demand, certainly not automatic, but even manually. It just wasn't built or designed into the system. And although our engineering teams were agile themselves, we had difficulty with our agility overall, mostly because adding new features and enhancements in a large monolith now developed by many teams across the globe was difficult at best. And unfortunately, rollbacks were just becoming the norm. So yes, we had a problem and we all knew it. But what we also had was an opportunity that was not clearly visible to everyone. So initially, we formed teams to address the engineering problem with mandates to stabilize the platform, get well, you name it, we had that team. I'm sure you know the type of team I'm referring to, Tiger teams. We had them, I was leading one myself. And this came at the expense of pushing back on product development in the interest of stability first. And this helped to buy time, but it was very obvious that we were unfortunately just pushing a very big rock up a very steep hill. And so what we had was a platform where the wrong technology was being used for the job, specifically Java for call processing. We also had a large monolith, which although we began to break it apart, actually breaking it apart into true microservices would have taken many, many years with very high levels of risk. And although our platform was in a public cloud, it just wasn't designed for the cloud, and there's a very big difference. So all these things combined were certainly a problem, but it was also a great opportunity for Vonage. So why was this an opportunity, you ask? It certainly didn't feel like an opportunity at the time for many, especially for those engineers, myself included, spending many nights and weekends struggling with the platform. The reason this was an opportunity was with all the problems we had, for which there was no magic bullet to fix. It presented engineering with the problem that the only way to fix it was to redesign the platform, specifically starting with our call processing platform, which was the largest and most critical component of our overall platform. And this meant that we now had the opportunity to choose the right tool for the job for each and every component of the platform. We could start with a clean slate, no tech debt, no legacy code, no restrictions, no porting code, just maintain prior business functionality. So truly be a greenfield effort. We also decided that we would not reinvent any wheels, and where it made sense, we would absolutely leverage open source technologies. The advantage we had today, which was not there when our prior platform was designed 10 to 15 plus years ago, was that many open source technologies had emerged and had become much more mature, especially in the area of voice over IP. When we started this effort, we gave the team the mandate that they could and should use all cloud native services. And this meant not just using virtual servers and object storage in the cloud, which is where most organizations stop in their journey. This meant if we needed a relational database, we would use a cloud-native managed database such as RDS, and we would provision that in our automation. If we needed a NoSQL database, we would use a cloud-native NoSQL database such as DynamoDB. If we needed a messaging framework, again, we would use a cloud-native messaging framework such as SQS or maybe Kinesis. There was no way we were going to start managing things like Kafka and Hornet and Postgres or MySQL or whatever, unless there was a really, really good reason to do so ourselves. The point here is that prior to this effort, we were not really fully adopting the cloud. We were just wetting our toes in the cloud, but now we were going to have the opportunity to go in with a cloud-native design. Project would also be an opportunity to form a new team from the ground up in a very fast-paced, high-tech environment. I've worked at many startups myself over my career, and for me, this was a chance to bring that startup mindset and an environment to a large organization and change our team culture. It was also decided from day one that our new team would be a true DevOps team. And this means that the same team, and oftentimes the same developer, which wrote the application, would also write the automation. The same team that deployed to dev would also deploy to QA and to production. And the same team that supports production will be the same team that fixes the bugs in production and builds new enhancements. One of the biggest challenges in our previous platform was that our large monolith made it very difficult to make changes. In our new design, using microservices was clearly something we can now design from the beginning, instead of trying to redesign a monolith into something it's just not. And from a scalability perspective, we would always look at the load curve of our customers' calling patterns and say things like, hey, we should really follow, use auto-scaling to follow the load curve of our customers. Wouldn't that be great? You know what? Getting there was always difficult from a call processing perspective. This is not simple HTTP request responses we're talking about here. We have to deal with long-lived calls using the SIP protocol with state. In a redesign, we're able to design for the complexity that autoscaling would impose on our call processing platform from day one. We also had the opportunity to start from a clean slate with a mandate that all of our infrastructure was disposable and very dynamic. Now, this means that tearing down and rebuilding our infrastructure from the ground up was something we would do not just on day one, but we would do it often. We do it daily in dev and weekly in QA and production environments. So now you can kind of see why this was an opportunity. It's not something that one comes across too many times in their career. We could build a brand new platform for a large existing customer base with a cloud-native design, using a microservice-based approach, run by a true DevOps team, and based on open source technologies, along with making all the technology decisions based on today, not a prior decade. Sign me up. However, it can certainly seem daunting to think that you do need to redesign a platform that serves millions of endpoints and many hundreds of thousands of customers. Where do you even begin to start with an effort like this one? Common thinking says you should never rewrite the entire platform, that it's just too risky and will likely fail. We have many naysayers who said this project was just too big. However, you have to weigh that against the risk and the effort of trying to fix this in small bite-sized changes. It just becomes a time that you can no longer patch all those rust spots in your car, and if you still need a car, you either have to do a frame-off restoration, which means you have no car to drive during that time period, or you need to build or buy a new car. In our case, we chose to build a custom car, unlike any other, where many parts, like the engine, were open source. So we didn't have to build and maintain all of the parts ourselves. We could instead leverage large communities of open source developers and focus our internal efforts on differentiating features and capabilities of our overall platform, while at the same time contributing back to the open source community. So first things first, we spent a few months with just a couple engineers, myself included, creating a proof of concept to prove some basic fundamentals. In our case, we did a POC where we leveraged the latest open source technologies in voice over IP, specifically around FreeSwitch and Asterisk, where we demonstrated the performance benefits of using the right tool for the job, specifically call processing. And this was a powerful POC, and we used it to make the case to our leadership team in engineering that this was the right direction. And this allowed us to take what was essentially a skunkworks type of project and bring it to the forefront of engineering efforts. We then decided that we would go into maintenance mode on our existing platform and push back on new enhancements, with, of course, support from our product organization. And we would do this until the new platform was ready, which we estimated to be about 6 to 8 months to build or to get to our MVP, along with another 6 or 8 months to complete the build and migrate our customers. However, we still had to run the business, and as an organization, this meant the existing legacy call processing platform was still evolving, and it became our responsibility, or burden, depends on how you look at it, to catch up with whatever changes had been implemented along the way. In some ways, this also kind of motivated us to get the job done. As mentioned, we started small, not just with the POC, but also once we had the green light to move forward. We essentially started to absorb new engineers on the team every few weeks. And I truly believe that if we threw too many engineers at the problem too soon, it would have slowed the entire effort down. So instead, we would bring on 1 or 2 engineers at a time. We'd ramp them up and then use them to help ramp up the next set of engineers. And this also helped because what we found is that the more work we did, the more items we crossed off our list, the more items we were simply adding to the end of the list, especially in the early phase of our redesign. And the main point here is to grow the team. Don't just throw a large team at the redesign from the beginning. Empower a small team. Over an 8-month period, we grew the team from approximately few to something like 20, and we upskilled each and every member on the team on new technologies in the process. And one very important point to make, which made our redesign successful, is that we often took an approach where if we were presented with two options to integrate the platform into the overall service, one which required less overall work within our team but had a dependency, let's say, on another team, versus spending more time on the team to build adapters, so that there was no external dependency at all, the latter option would always be given more weight. And that's exactly what we did. We often took on more work within our team to build adapters to the rest of the system than to try to change the rest of the system that we were integrating into. And this allowed for autonomy, which was critical to success and created much less friction overall. Now, it doesn't mean we never asked another team to make a change. It just means that we always gave heavier weight to an option which allowed our team to solve a problem end to end. So, what was it like to be on this team while we were running just to get to the starting line of our MVP? Make no mistake, even though Vonage is a billion-dollar public company, this team was functioning and operating with a startup mindset, where the risks were high, we were learning something new every day, significant pivots were not uncommon, and unfortunately 16-hour workdays, including weekends, were also not uncommon. But not because anyone was forced to do it. Because we were passionate about what we believed in, and we truly loved the work, like a startup. Certainly was not the environment depicted here in Office Space by any means. The culture of the team was an important piece of this journey to get to the MVP as well. During our initial MVP development phase, the culture of the team was one where embracing new technologies was highly encouraged, even if there was no one on the team for that technology. Making mistakes was not negative, it was just part of the process. We felt empowered to make almost all decisions within the team, being fully autonomous. And during our initial MVP build phase, the team also started to embrace DevOps skills. And this meant that a developer who previously was only writing, let's say, Java code for an enterprise monolith was now not only writing code in multiple languages such as Java, Python, Lua, C, or C++, but the developer was also writing their own automation in Ansible and making sure their components could be built and deployed in a fully automated fashion. Developers were now also spending time implementing monitoring solutions for their applications, ensuring their applications could be deployed, scaled, and monitored in all environments the same exact way. This way, when we got to production, there would be no surprises. It would be just another environment. We even went so far that every week we automatically destroyed every developer environment without warning. Certainly after a few mistakes where developers lost code because they didn't treat their infrastructure as disposable, they eventually learned and appreciated the need to fully automate everything, which meant that code needed to be pushed to all environments through pipelines, even dev environments. And as you can imagine, a project like this can go against the grain of the status quo in an enterprise environment, which can certainly be disruptive to many. However, with support of engineering leadership, our team essentially had the mandate to disrupt the status quo, and that's exactly what we did. Everything was fair game. No one was going to dictate to our team what technology or what process or what tool to use. Our team would decide for good or bad. There were, of course, we had some boundaries when it came to things like compliance and security, but for the most part, we were disrupting the organization on many fronts, in a good way. Prior to this effort, Vonage had already long completed an enterprise Agile transformation. And this was done many years prior, so most everyone on the team had already been functioning in a formal Agile Scrum environment. This is what the organization knew how to do. However, like I said, everything was on the table for disruption, including our Agile process. So what we quickly found was that our Agile Scrum process, which had worked so well for previous projects, it just didn't fit well within the early phase of our redesign. So we redefined that process and to make it work for this team, and that's where we chose more of a Kanban-based approach. The overhead of 2-week sprints and ceremonies using Scrum was just not going to work. We needed to iterate more quickly than that, and we needed to allow for change at any time. And trust me, there were lots of unknowns and lots of change. In this phase of our journey, simply a less formal Kanban methodology was just more suited. So let's take a quick look at the timeframes we're talking about for the redesign. As I mentioned, we initially started with the POC in the fall of 2016. And this effort was a relatively small team, just a team of 2 hacking away to demonstrate the feasibility of our cloud-native, open-source-based proposed solution. And during this period, we were transitioning away from our prior responsibilities and working on this POC essentially as a side project. And this effort was kept mostly under the radar within engineering as a research project until we could prove to our peers that this was the right direction for the company. An important point here is that we were not designing around our existing organization structure. We were designing around what was right for the platform, our customers, and the business. Everything else would have to fall into position around that direction. And once we were given the green light to move forward in early of 2017, we went into a heads-down development mode, and we started to build the team and build the platform towards our MVP. And during this phase, we had to figure out how to redesign each and every component of our platform, which included subsystems such as presence and voicemail and conferencing and queuing and SIP registrars and SIP proxies and transcoding and CDR mediation and provisioning. Each and every one of these subsystems started with a single line of code, oftentimes built on top of an open source foundation. There just was no other way. We also had to re-implement each and every feature of our call processing service, such as virtual receptionist, call groups, call parking, call queues, busy lamp field, share line appearance, call recording, call monitoring, and many, many more features. Again, each one of these features started with a single line of code. Instead of looking at the complex spaghetti code of how these features were implemented in our legacy monolith, we started with what was the expected behavior from a customer perspective and how were they provisioned in our database. And we started from that point. Here it took us 8 months to build the basic features and subsystems needed to get to our MVP, which on August 10th of 2017, we got to the point where we migrated our first customer. And from that point forward, we were now in a very different mode, where this was no longer work being done in lab environments only. We were now building, deploying, and supporting our platform in production. We were also migrating customers onto this platform within the same team. And the feedback loops here were very tight, and we were able to iterate very quickly. We relied heavily on our automation to allow us to deploy new code in a matter of minutes if needed, and rebuild our entire production environment during the day with live customers on it as needed. And we did this often. During the fall of 2017, we had migrated about 30% of our customer accounts. We then took a breather to let things soak through the holiday period. We then hit the new year in 2018 with the ground running, and by May of 2018, we had migrated 90% of our customer accounts. As typical, the last 10% took 3 months, and from our starting point on August 10th, 2017, where we had just one customer on our new platform, a year later exactly on August 10th, 2018, we had just one customer remaining on our old platform. So we were essentially done with the redesign at that point in time. So, okay, I agree this might be a little bit over the top, but I do like to think that after our redesign, we now have the holy grail of UC platforms. You know, when we started this project, I would always tell folks that, in a year or so from now, I just didn't want to be talking about all the problems we had and we should do this and we should do that, but nobody actually doing it. I'm sure you all know how fast a year can go by, but I also knew how much a relatively small team could get done in a year with the mandate and the direction and the determination. And we did that. We got there. Now all of those water cooler conversations about all the things wrong with our platform no longer occur, at least not in front of me. But seriously, the one thing I'll be honest about is even though we're done and we made it to that finish line and completed our initial mission, we're not done. We keep going. Our platform continues to evolve, and every day as a team, the culture of disrupting does not have any boundaries, including within our own team. We're constantly evolving the platform, and when and where necessary, we continue to redesign and rewrite components as we see the need. With that said, though, let's take a look at our holy grail of UC platforms today after our redesign. So today, after our redesign, our VBC platform has had a heavy investment in automation. We mostly use Ansible and CloudFormation, where we leverage integration with AWS SDK very heavily to make our automation do things in the cloud that we simply could never do before within our own data centers. We treat our infrastructure as code because it is written and it is maintained by our developers, the same ones which write the applications which leverage the infrastructure. We now have automation in place where rebuilding all environments from scratch, including dev, QA, and production, occurs on a frequent basis, as I had mentioned, daily in dev and weekly in upper environments. We leverage blue-green deployments, which allow us to rebuild even our production environment while we have live active calls on it without having to perform any failover maneuvers. And we can do this because our automation and our applications work together to make a platform which is now cloud native. We also now have CI and CD using AWS Code Deploy and Code Pipeline, where we deploy multiple changes a day, and we push those changes to our environments with a simple click of a button. We push out changes to some of the most critical components of our real-time communication platform through Code Pipeline and Code Deploy. This includes routing logic to our SIP registrars and our SIP proxies, as well as dial plan logic for our real-time application servers, as well as software for many microservices, whether they are Python, Java, or Node-based. We have more than 20 or so distinct pipelines alone on our call processing platform to deliver code to any given environment. And all this automation allows us to now innovate at a very rapid pace. Today, our VBC platform has a very dynamic and elastic infrastructure. We use auto-scaling groups with EC2 and CloudWatch such that our infrastructure scales out horizontally to match demand and scales in when demand decreases. And to support auto-scaling on components of our platform, which process voice and video calls, this means we had to treat our infrastructure as disposable from day one. This means any file written to disk, whether it's a call recording or a CDR, needed to be uploaded to S3 since that instance could scale away at any time. We also now use serverless Lambda functions for processing every call event on our platform. This means every telephony event, such as a call is ringing, a call is alerting, a call is answered, or a call is terminated. Each and every one of these events needs to be processed and consumed by other parts of our platform to maintain dashboards and features which rely on these events. On our real-time call processing platform, whenever one of these events occur, we simply invoke a short-lived Lambda function in the cloud, and we process these events in a serverless piece of code which is highly elastic with zero maintenance. You can imagine the timing of these events are very critical. With cloud-native serverless Lambda functions, we have been able to easily scale to well over 6,000 Lambdas a second during peak periods of our traffic. And one fun fact that I think is worth mentioning is that on our VBC platform, we are actually using what I call serverless SIP functions. That's right, we are actually sending SIP messages from small pieces of Python code running as serverless Lambda functions in the cloud. We use this specifically for publishing events to our presence subsystem, which essentially can turn lights on or off on desk phones for things such as message waiting indicators and shared line appearance functionality. But basically, there's no server, there's no container, it's just a piece of code running in the cloud, generating a SIP message in response to some event. I think that's kind of cool. For some existing applications where maybe an object store such as S3 is not feasible, we have been able to leverage cloud-native elastic file systems and have a highly elastic file system which simply grows as our demand increases. There's no more managing NFS infrastructure ourselves. Today, our VBC platform is designed such that even our call flows take advantage of not only a multi-AZ architecture, where calls are processed in clusters which are active across multiple AZs or data centers within a region, but these call flows also know how to automatically fail over to another sister region, which is active as well for other customers. With auto-scaling, if and when a cross-region failover event or a need occurs, the capacity in one region will simply scale up to meet the increased demand from the other. For our customers, this means they benefit from the fact that we essentially have 6 data centers across 2 geographies in a public cloud environment, providing their service, all of them being active at the same time. No cold or warm standbys, no failing over to another region if just one physical data center goes down. Of course, we also leverage many cloud-native managed services such as RDS, Elasticache, EFS, Lambda, and many others, which are also highly available themselves within a region. When building a cloud-native HA platform which leverages these services, you'll always want to make sure you have a button to exit a region, literally with a simple yet secure click of a button. Failures won't always be black and white, unlike this catastrophic failure of a jet engine, which illustrates the importance of high availability. There can be gray types of failures. And for this reason, you want to make sure you have that button to get out of a region for any type of gray failure, in addition to automatic failover as well. Today, our VBC platform leverages, as I mentioned, many managed services in the cloud. And by redesigning our platform for a cloud environment, we're able to natively leverage many services that previously required much time and effort to manage ourselves. Now, why would you want managed services? Well, when you're self-managing your own services, such as database, object stores, and message buses, no one ever notices when it's working. They only notice when there's a problem. It's overhead to your organization, and it does not help to differentiate your product from your competitors at all. With managed services, you get all the benefits of a dedicated team living and breathing their service for you. As an example, we now use RDS for all of our relational database needs, such as account data and usage data. We also leverage DynamoDB for microservices, which need to manage global state, such as the state of an agent in a call queue. And for distributed real-time caching, such as that needed to manage the state of a call, we rely on Elasticache Redis. We also leverage Elasticache Memcache for managing real-time transient registration events. We pump all of our CDRs into a Kinesis stream, which our mediation system uses to process those records and perform mediation prior to rating. As the usage on our platform grows, we simply add more shards through automation to our Kinesis streams to get more throughput. It's that simple. And since our platform is very elastic and we try to optimize keeping as much data as close to our call processing components as possible, we leverage SNS to decouple the job of publishing account changes. We also leverage SNS. We also leverage SQS to distribute our microservices across our Elastic infrastructure for jobs such as transcoding call recordings, converting documents for fax transmission, and storing voicemail recordings into long-term storage, as well as many other use cases. And of course, all of these services, including the creation and discovery of these services, are baked into our automation so that a single button can be used to provision everything needed for an environment. Seriously, listen to me here. Invest in automating everything. The return on investment is definitely a game changer, and the programmability that you get in cloud environments it's just a key differentiator compared to legacy practices that are still used by many others in our industry. Today, our VBC platform is running its workload in a public cloud environment, and it's providing a high-quality, low-latency service. In order to achieve this result, we specifically use EC2 instances with EBS volumes for most of our signaling and media processing components. For most of this workload in AWS, we have found that the C5 instance type with the Elastic Networking Adapter provides the best throughput, specifically in terms of packets per second, with extremely low latency, which is critical for any real-time communication platform. And in order to ensure a high quality of service, we have invested efforts in what we call fast auto-scaling techniques to make sure our call processing instances can be launched and brought into service within minutes. And this is necessary to ensure our platform can take any punch which comes its way and still maintain high levels of quality. Kernel tuning is something that just goes with the territory with any real-time communication platform. We found that tuning the clock source and the schedule of the kernel are important factors towards maintaining high quality and low latency. You also want to make sure you profile your kernel not just under load test environments, but also on production workloads where possible, of course. Migrations. This is something that usually every enterprise has occurring across the organization for various initiatives, oftentimes many in flight at the same time. Whether it's migrating your internal users from legacy Exchange servers to Gmail, or whether it's migrating your source code repositories from legacy SVN or CVS to GitHub, it seems the enterprise is on a never-ending journey, migrating from one system to another. However, when a migration involves your customers and impacts the service you're providing to them, that is a whole different category. It's certainly not good when your IT department fouls up a migration of your internal Jira ticketing system, let's say. But if a platform migration causes your customers to lose service for which they trusted in you to provide, then you have an entirely different situation on your hand. During the initial phase of our platform redesign, where teams were busy building the platform in a dash just to get to the starting line, we also had a dedicated team that focused building tooling to support those migrations. And this is an area that you just can't neglect. You're going to need it, and you're going to need to invest in the tooling. There's just no way around it. You must invest in the tooling to automate as much of the process which involves moving a customer from an existing platform to a new platform. And one important part of this tooling is the ability to profile your customers. And what I'm talking about here is building tooling which looks at your customers and mines data from as many sources as you have in order to determine which features and services are being used by each and every one of your customers. If you go really deep into understanding how your customers use your platform, then you'll be able to use this information to plan your implementation strategy in an incremental fashion. Without it, you'll have to build the entire thing and then migrate. And that is not a recipe for success. You must build and migrate in parallel. And that is exactly what we did. We raced to the starting line with our MVP, which we knew could meet the capabilities of our most basic customers. Our profiling dictated which features we would have to implement next in order to meet the next wave of migrations. And this strategy allowed us to fail fast and build a platform in an incremental fashion with a very carefully planned and orchestrated migration. However, as careful and as great as you think you are, it's inevitable you will screw up and something will go wrong. Remember, you want to fail fast so you can find problems and fix them quickly. And when something does go wrong, you must have support for rollback built into your tooling. We invested heavily in tooling which had the ability to move customer phone numbers from our legacy platform to our new platform and back again with a simple click of a button. We also had the ability to reprovision our customer endpoints from our legacy platform to our new platform and back again with a simple click of a button. We also had the ability to move things like customer voicemails and call recordings and such, again, from our old platform to our new platform and back again with a simple click of a button. When we first started migrations, it took us hours each night. And I'm talking like 5 hours a night up until 3 a.m. just to migrate a handful of customer endpoints. By the end of our migration, we were migrating tens of thousands of customer endpoints each night in just an hour. And that was a result of a massive investment in our migration tooling to get us there. When you do finally make that decision that it's time to overhaul your platform, you'll need to find leaders on your engineering team which have a customer-first mentality and put them in charge of your migration and implementation strategy. And the mentality here must always favor heavy engineering investment to reduce customer friction at all costs. And this is not only true of the platform you're building, but also of the migration tooling to get there. As we were rebuilding our platform, it seemed like there was never a good time to start migrating. But at some point, we had to jump in the water and start those migrations. So we kept a sharp focus on getting an MVP that we knew could meet the most basic customer based on our profile. And I can't stress enough how important it is to get to the starting line as soon as you can. But this means you'll be migrating some customers without having finished the implementation for your next wave of customers. And that's exactly what we were doing. We were building and migrating in parallel all the way to the end, the very last customer, literally. And you'll learn the entire way, and that's why you need to start early. Let's talk about the results of the redesign of our Vonage Business Cloud call processing platform. Before our redesign, we had thousands of servers in AWS, and I'm talking like many thousands of servers running at very low density, again, because of the garbage collection issue. Probably we were only doing approximately 30 concurrent calls peak. After our redesign, we now have hundreds of servers of the same instance type running at a much higher density, about 300 concurrent calls peak. It's basically a factor of 10x improvement in both dimensions. And although our objective wasn't necessarily a cost savings exercise, we estimate this effort saved approximately $1 million a year in cloud costs alone. Before our redesign, it was challenging at best to maintain high reliability levels for our customers, achieving less than 5 nines of reliability, unfortunately. Today, we maintain 5 nines of reliability, and we see this reflected in our customer surveys with a dramatic staircase trend downward each quarter in customers who report issues with stability and reliability of their service. Before our redesign, call quality was a challenge to maintain with garbage collection issues in Java under various conditions such as high spikes in calls per second. Today, we are able to maintain MOS scores of 4.2 or higher under conditions of high call volumes, high calls per second, and even under failure scenarios. Chasing down issues of call quality induced by the platform itself is simply no longer a concern or a drain on engineering resources. Before our redesign, scaling our platform was done through careful capacity management and deployment of additional infrastructure manually to support growth. Today, with a platform that supports auto-scaling for call processing, we no longer add capacity manually to handle growth. This is something that just happens all day long. As call volume increases during the day or at any other time, servers are automatically brought into service, and as traffic ramps down, they are taken out of service, the traffic is drained, and then they are terminated. Of course, I'm simplifying tremendously what it takes to achieve this from a call processing perspective, but the elasticity of our call processing platform has been a game changer for us. Before our redesign, the agility of our platform often involved release cycles on the order of months, often with rollbacks. Getting even the smallest change out to production had a tremendous amount of overhead and risk. Today, we deploy multiple changes to production across all components of our call processing platform. We often add new features from dev to QA to production in just a matter of days. And this alone has completely transformed our ability to deliver new features and services to our customers. All of this was a direct result of our decision to completely redesign our call processing platform from the ground up, because there was just no other way. This was just the simply thing to do. It was truly a unique opportunity for Vonage. And I hope our story inspires you that when the time is right to take on that big redesign project. There's a saying, if you don't rewrite your software, someone else will do it for you. And it just might be me. Thank you, everyone. Here's my email if you want to reach out to me afterwards.